Welcome to all. Today's topic is to learn what is an evaluates and inevaluates. So evaluates is the locus of a curve of all center of curvatures. So the center of curvature are already studied in previous class, and which is closely connected to inevaluates. Okay. The major application of this inevaluates and evaluates is to use a gear tool to avoid the vibration in your vehicles. And evaluate is internally connected to inevaluates. Okay. So this is the major application we have seen for evaluates and evaluates. And we are going to solve some problems, especially for the parabola, hyperbola, ellipse, asteroid, and so many curves is there. We have to know the working procedure, how to solve these type of curves. Okay. The first one, working procedure. The first point is, for a given curve, y equal to f of x. I am taking a Cartesian curve. So this is the curve they are given in the problem. First we should have to use the parametric form. We have to change the curve in the form of a parametric by taking some substitution for x as well as for y. Okay. The second point is, for a given curve y equal to f of x, choose parametric equation. Choose parametric equation which is in the form of x equal to, it is a function of t, either theta, that is your convenient. Either you can use t or either you can use theta, and y equal to y of t. So this is the first procedure. For a given curve, you have to change the given curve y equal to f of x in the form of a parametric equation. This is the first procedure to find out the evaluates and inevaluates. Okay. The second procedure is, using this parametric equation, we have to find out the derivative of the function. Find dy by dx, or simply we can call as an y1, and d square y by dx square, simply it is y2. The second procedure means taking this parametric curve, how to differentiate this one. Okay. And that means two equations is there. You combine that two parametric equation in the form of dy by dx and also d square by dx. Next, after find outing this, we have to find out the center of curvature. Find the center of curvature. That is an x bar comma y bar. Use the formula for x bar like this, center of curvature. This is an x minus, it's y1 into 1 plus y1 square, then all divided by y2. This is for x bar, and y bar should be equal to y plus 1 plus y1 square, then all divided by y2. The third procedure means you have to find out the center of curvature. After find outing the center of curvature, the equations are obtained in terms of t or theta. Parametric form is there now. We are going to eliminate the parametric form using this x bar and y bar. Eliminate. It's a parametric equation. T will be present in both the equation. How to eliminate this one? Eliminate parametric variable using x bar and y bar. That is the center of curvature. That using that two equation, you have to eliminate the parametric Okay. So then finally replace, after eliminating the parametric equation, that is a parametric variable is there now, the third variable is there, you have to reduce the equation in terms of two variables, that is in Cartesian form, what they given here. Okay. Then replace, that is the fifth one, replace x bar comma y bar should be equal to x comma y. So this is the procedure, detailed procedure we have to follow to construct and evaluate for a given curve. Okay. So I will explain again working procedure to evaluate and evaluate of a given curve. The first, for a given curve, you should have to change in terms of parametric equation, depend upon their curve. The second one, using this parametric equation, you have to find out the first order and second order derivative. In the third step, after finding out the first and second order derivative, then you have to find out the center of curvature. This is the formula we are used for center of curvature. Okay, that is x bar is x minus y1 1 plus y1 square by y2, then y bar equal to y plus 1 plus y1 square by y2. In the third, that is fourth, to eliminate the parametric variable by using these two center of curvature. Okay. In the last step, after elimination of the third variable, what they obtained in the parametric equation, in the center of curvature, you have to replace your x bar, y bar in terms of xy. This is the complete procedure to understand, to form and evaluate or inevaluate of a given particular curve. Okay. So now we are going to solve some problem to understand how to construct and evaluate or inevaluate of a given curve. Okay. Show that, sometimes they ask like that, show that evaluate, show that evaluate of the curve, evaluate of a curve y square equal to 4ax, y square equal to 4ax is in the form is in the form 27 ay square should be equal to 4 times of x minus 2a whole to the power of 3. So this is the problem they ask in the examination like that. Show that evaluate of the curve, that is y square equal to 4ax, it represents a parabola, is in the form of the evaluate of a curve y square equal to 4ax should becomes in the form of 27ay square is equal to 4 times of x minus 2a whole cube. Okay. So already I told in the working procedure, for a whatever the curve they given, you should have to know the parametric form of a curve. So what the curve they given here, y square equal to 4ax. It represents an equation of parabola. Represent equation of parabola. What is the parametric form of the parabola? You have to remember. The parametric form is form of parabola is x equal to 80 square and y equal to 2 times of 80. So this is the parametric equation. That is x equal to 80 square and y equal to 280. This is the parametric form. Okay. So this is the first procedure. In the procedure number 1, the first step will be over. This is the curve is a parabola. We identify that. Then after that, you have to change the parabola curve in the form of a parametric equation. What is the second procedure? Now we are going to differentiate this one and make it as in first order derivative in terms of dy by dx. Now differentiate this one. Differentiate. Both have to differentiate with respect to t. Differentiate with respect to t. You have to differentiate both the equation. Because x is depend on t. For the parametric equation, we convert one more parameter will be applied, that is t. It is depend on x as well as y. Okay. If we differentiate this one with respect to t, we get dx by dt, that should be equal to 2 times of at. Then again, the same thing we have to differentiate this one. This become dy by dt should be equal to 2 times of a. Okay. So what is the next step? I wanted to dy by dx. Now your dy by dx is a parametric form converted to an ordinary derivative with a two variable. It should be changed like this: dy by dt, then all divided by dx by dt. You have to write down like this. What is your dy by dt? This become 2a, then all divided by. This is your dy by dt. Then dx by dt is 2a t. Now cancellation of these two, we get dy by dx should be equal to 1 by t. Now I got the first order derivative in terms of t. Now find out the next procedure is, now I am going to find out the second order derivative. If you want second order derivative, this one differentiate with respect to x. I wanted to second order derivative in terms of x. Differentiate with respect to x. What we get now here? This become d square y by dx square should be equal to. What is the differentiation of 1 by t with respect to x I am doing now? I have to be careful about here. With respect to x, this is minus 1 by t square into dx by dt. The differentiation of t with respect to is minus 1 by t square. T with respect to x is, that is dt by dx, not dx by dt. It is dt by dx. Remember this one. Minus 1 by t square into dt by dx. Okay. Then d square y by dx square should be equal to minus 1 by t square. Now substitute the value of dt by dx. See here. We have dx by dt. I wanted to dt by dx. This become 1 divided by 2 times of t. Now to substitute this one using this relation. Then we can also call simply as an y2. Second order. It is a minus 1 by 2a into t power 3. Now I got both first and second order derivatives. What is the next procedure? So after finding out y1 and y2, I am moved to the working procedure number 3. That shows that we have to find out the center of curvature. Next, to find center of curvature. To find center of curvature. Center of curvature. That is an x bar comma y bar. Now I am going to find out the center of curvature. What is x bar? We know the formula. X bar equal to x minus times of y1 by y2 into 1 plus y1 squared. Make a substitution. You have to x bar equal to x minus. What is y1 now? See here. Y1 is, or simply this one we call as an y1. It is 1 by t. You have to write down here. in place of y1 1 by t, then whole divided by y2 minus 1 divided by 2a t power 3 into 1 plus, again use this relation, 1 plus t whole square. Now make a simplification work. Your x bar equal to minus by minus, this become plus, x plus, it shift to numerator, 2a t cube divided by t into 1 plus 1 by t square. Then x bar equal to x plus, now cancellation of these two, we get 2a t square into 1 plus 1 by t square. Now multiply this t inside this function, we get x bar equal to x plus 2 times of a t square plus, then multiplied here, this is 2a. Now I got the x bar value like this. X bar is x plus 2a t square plus 2a. And also you have to remember one thing. We know the value of x. X is a parametric form. You have to use this. X is a t square. You have to use this one also. Then x bar should be equal to, use this, the a t square plus 2a t square plus 2a. Now add these two. We get x bar should be equal to 3at square plus 2a, or our convenient form, we can write down x bar minus 2a equal to 3at square. This is your x bar. For simplification purpose, we can write down x bar minus 2a equal to 3a t square. Okay. Or I wanted to t, we can also write down x bar minus 2a equal to 3a equal to, that is t square. I want to t of powering of that one. We can also, or we can also write down x bar minus 2a divided by 3a equal to t square, or t is x bar minus 2a divided by 3a. Now call this as equation number 1. This is the detailed procedure for finding out the value of t. The center of curvature, you have to remember, this is x bar. 3at square plus 2a is the center of curvature in terms of x. I wanted to find out y bar also. Again use the same formula for y bar. One by t, then y2 is minus 1 by 2a t power 3, then t is x bar minus 2a divided by 3a. Now y bar. To find y bar. What is the formula? Y bar equal to y plus 1 plus y1 square, then whole divided by y2. This is the formula for y bar. Then after that, you can substitute directly. The y value is, it is 2at plus 1 plus y1 square, 1 plus 1 by t square whole divided by minus 1 by 2 times of, shift to numerator, then plus divided by minus 2at, it is a minus times of 2at cube into 1 plus 1 by t square. Then multiplied inside that particular term, 2at minus 2at power 3 minus, these two are cancelled, we get 2at. So remember, if you multiply this term inside, 1 into 2a power 3 is 2a power 3, plus into minus minus, then you shift to numerator, t t square will be cancelled, remaining 1t will be cancelled. These two are cancelled. Then we get y bar is minus 2 times of, I'll call this as equation number. Now using 1 and 2, we are going to eliminate the value of t. Then after that, it gives the center of the evaluate of the curve in this form. Okay. Now using 1 and 2, now using equation 1 and equation 2, I am going to using these two. Using equation 1 and 2, we eliminate the value of the parameter t will be appear in this t, and also use this one. Using 1 and 2, eliminate parameter t. Just you substitute the value of t in equation 2, equation 1, substitute in equation 2, then you make a simplification of work. The equations are reduced in terms of x and y. Substitute equation 1 in equation 2. What we get now? Y bar should be equal to minus 2a. And I have to remember this is an whole to the power of, equation 1, this is t square, that is t square is x bar minus 2a by 3a. I wanted to t here. What happened? This become x bar minus 2a 3a whole to the power of, it is 3 by 2. Remember here? So t square is x bar minus 2a by 3a. Okay. So I wanted to t is, it is an whole to the power of x bar minus 2a whole divided by 3a whole power of 1 by 2. It comes here, is become 3 by 2. Then powering, I don't want this 2, squaring both sides, like that. If I wanted to 3, then squaring both sides. What we get now? Y bar whole square should be equal to, negative become positive value, this is 4a square. Then we have x bar minus 2a whole divided by 3a whole power 3. So I wanted to in this form, this power should be split to both numerator as well as denominator. Then what we get now here? Y bar whole square should be equal to 4a square, then x bar minus 2a whole power 3, then whole divided by 27a power 3. That is in 3a whole power 3. It becomes 27a power 3. Now this a square and along with a cube will be cancelled. Then we have y bar should be equal to 4 divided by 27a into x bar minus 2a whole power 3. Make a cross multiplication. 27a y bar whole square equal to 4 times of x bar minus 2a whole power 3. Now the equation should be in the form of center of curvature. The next step is replace x bar y bar should be equal to x comma y. If we replace that, we have 27a y square should be equal to 4 times of x minus 2a whole power 3. So this is a required evolute of the curve y square equal to 4ax. Is it? So this is the way we can solve this problem. Okay. So one more problem I am going to solve to understand the same concept. Now take on the second problem. In the second problem, show that evolute of the curve, that is x square by a square plus y square by b square equal to 1. Here the ellipse equation will be given. Using that ellipse equation, you have to show the evolute of this curve in this form. Ax whole power 2 by 3 plus by whole power 2 by 3 equal to a square minus b square whole power 2 by 3. Okay. Now solution. So first we write down the parametric equation of a ellipse, equation of ellipse. The parametric equation of ellipse is, what is that? It is an x equal to a cos t and y equal to b sin t. So this is the parametric equation for x and y. Okay. So after writing this parametric equation, what is the next step? I am going to find out the first and second order derivative by using the parametric equation. Now differentiate with respect to t. Here also differentiate with respect to t. Both the equation I am going to differentiate with respect to t. We get dx by dt should be equal to minus a times of sin t. Okay. Then dy by, this is also dt, should be equal to b times of differentiation of this. With respect to t, I am doing this one. Now I wanted to dy by dx. If you want dy by dx, you can write down the equation. Dy by dx should be equal to dy by dt, then whole divided by dx by dt. What is your dy by dt? It is b cos t, then whole divided by a times of sin t minus. We know that cos by sin, it is a cot. Dy by dx should be minus b by a into cot t. Now I got the first order derivative. What is your first order derivative? You can also call as an y1. Our first order derivative is minus b by a cos t. Is it clear? Okay. Now after finding out this first order derivative, now we move to find out the second order derivative. Now again differentiate. Again differentiate with respect to x now. Now differentiate with respect to x. What do we get now here? It is d square y by dx square, or simply we can also call as an y2, minus b by a constant. The differentiation of cot is minus cosecant square t into, I am doing a differentiation with respect to x now, not t. You have to differentiate t also. This becomes dt divided by dx. Then y2 is minus into minus plus b by a cosecant square t into dx, dt by dx. What is that dt by dx? We know the value of dx by dt. Now I am going to substitute here now. I wanted to dt by dx. Just you take the reciprocal of this. This becomes minus 1 by a sin t. And finally we got y2 is minus times of 1 by sin is cosecant. We can write down the answer. We know the reciprocal of sin is cosecant. The reciprocal of cosecant is sin. You take a reciprocal of this, become a cosecant. It is minus b cosecant cube t divided by a square. Now I got the second order derivative. So first order and second order. After that, what is the next procedure? If we find out the first and second order derivative, now we are going to find out the center of curvature. Now to find center of curvature, then you move to find the center of curvature. What is that center of curvature? That is an x bar, comma, y bar. X bar, I am writing the formula. X bar is x minus y1 into 1 plus y1 square, then all divided by y2. Now substitute the respective values. We know that x value, y1 value, y2 value. Using all this, I have to substitute here now. What do we get now here? X bar should be equal to, what is the value of x? The value of x is a cos t. A into cos t. Then y1 value, put a negative. Then y1 value, what is that y1 value? Minus b by a cot t, then all divided by minus b by a square cosecant power t into 1 plus b by a cot t, the negative will become positive, that is a b square a square cot square t. X bar should be equal to a into cos t, then minus 3 and a minus, these two are cancelled, we get minus, then one b will be cancelled, here also b will be cancelled, and one of the a will be cancelled. Finally we have minus it comes like that, minus b by a into a square by b cosecant cube t into cot t into 1 plus b square. Cot we can write down in this form of cos square t divided by sin square t along with a square. If we make a simplification of this, a cos t minus these two cancelled, we get a into cos is cos t by sin t. You can write down the cot in this form, cos t by sin t. 1 by cosecant is become sin cube t into 1 plus b square cos square t divided by a square sin square t. So the simplification, these two are cancelled. We get a cos t minus a times of cos t sin square t into 1 plus b square cos square t divided by a square sin square t. Now multiply this term for these two. A cos t minus, you multiply it inside, this become a cos t into sin square t, then plus into minus, minus. If you multiply it, one of the a will be cancelled, we have b square and sin square both are cancelled, then we have cos cube t. Here this one of the a will be cancelled and the denominator we have a. If you multiply it here, 1 into this term a cos t sin square t, minus into plus minus, then one of the a will be cancelled along with, we get a, and sin square both are cancelled, we get only cos t. then cos t into this cos square, they become cos cube. Okay, from these two, take a common factor of a cos t. A x bar, this is a. If I am taking a cos t, then it becomes 1 minus sin square t minus b square cos cube t divided by a. Now use the identities of trigonometry. You can write down 1 minus sin square as a cos square t. Then x bar should be equal to a cos t into 1 minus sin square is cos square t minus b square cos cube t divided by a. The product of these two is also become a into cos cube t minus b square cos cube t by a. Now take the common factor of cos cube here also. It become a minus b square by a. Take an LCM. Multiplied throughout by a. Multiplied by a. This become a x bar equal to cos cube t a square minus b square. You get the equation in this form. Then after that, so this is one of the center of curvature point x bar. Why I am going to make a simplification work as they given in the problem, you have to prove like that. If I wanted to 2 by 3, taking a 2 by 3 both side, Q, apply power 2 by 3 both side. If you are applying 2 by 3 both side, it will give a x bar whole power 2 by 3 and should be equal to, we get only cos square t into a square minus b square whole power 2 by 3. Now call this as equation number 1. So one of the stage will be obtained. Okay, so I got ax whole power 2 by 3. So this is the step we are obtaining. Okay, in the same way we can find out the another coordinates of center of curvature, that is in y bar. Okay. Now to find y bar. What is the formula for y bar? The same. Y bar equal to 1 plus y1 square then whole power y2. Along with this, y bar equal to y plus 1 plus y1 square divided by y2. So respective values we have to substitute here now. Y bar equal to, we know the value of y, that is b into sin t plus, what about y1 now? 1 plus, if square is there, negative become positive, that is b square cot square t divided by a square, then whole divided by, then y2 is minus b by a cosecant cube t. Make a simplification work for these two. We get y bar equal to b into sin t plus divided by minus, you shift to numerator a by b, you go to numerator a by b, cosecant cube t into 1 plus, this is y2, this is related to this, 1 plus b square cot square. We can change cot in terms of cos by sin. Cos square t divided by a square into sin square t. B sin t minus a into, shift 1 by cosecant is sin cube t by b into 1 plus b square cos square t divided by a square sin square t. They multiplied this term here. Check what happens. If you multiply it inside, y bar equal to, just I am writing here now, in the equation 1 you have to remember, there is an ax bar 2 by 3 cos square t, a square minus b square 2 by 3. I am writing here now on another side. Add that too, will get it. Okay. b sin t minus, if you multiply it inside here now check what is the simplified form will be obtained. Minus a sin cube t by b, then again minus, one of the b will cancel, one of the a is also cancelled. We have minus b sin cube t cos square t, then all divided by, a will be cancelled, sin square will be cancelled, we have only sin t. Just I am writing directly. This isn't a b square sin cube t cos square t, then all divided by b a square sin square t. So this is and this is will be cancelled. B sin t minus a sin cube t by b minus of, one of the b will be term will be is there, then sin t is there, cos square t is there, then all divided by a is there. Sorry, this is an a square, you have to remember. So this is the term will be completely cancelled here now, a square. And this is your a square. This is also an a square. Both a square cancelled. We have only b. No, a will be obtained. Then y bar equal to, take a common factor from these two, b into sin t. Then we have 1 minus cos square t minus a sin cube t divided by, so write on this, y bar equal to b into sin t, then this also sin square t minus a sin cube t by b. Now product of this we get b into sin cube t minus a into sin cube t by b. From these two take a common factor of sin cube, then y bar should be equal to, if you take a common factor of sin cube t, it becomes b minus a by b. To make simplification work, this becomes sin cube t into b square minus a divided by b. So I think this is an a square, should have to write down here now. So this is an a square, just remember, this is also an a square, not an a, because a square sin cube by b is there. Now write down a square sin cube t, b like this. So become an a square, then a square. Okay, make a cross multiplication, b into y bar, you take a negative as a common factor, it becomes sin cube t into a square minus b square. Now again powering 2 by 3, both side, power is even, the negatives also become positive, we get p y bar whole power 2 by 3, you have to remember this, should be equal to, we have sin square t, then a square minus b square whole power 2 by 3. Now call this as equation number 2. See here. After getting equation 1 and 2, to remember, already I written equation, add equation 1 and 2. If I add equation 1 and 2, add equation 1 and equation 2. In the both the equation, you have to remember the LHS. Ax bar whole power 2 by 3 plus by bar whole power 2 by 3 should be equal to, in the RHS we have a square minus b square whole power 2 by 3 into cos square t plus sin square t. In the first equation we have cos square, in the second equation we have sin square. If we make a simplification of work, by bar whole power 2 by 3 should be equal to a square minus b square. So this is the value is 1 because the identity of trigonometry. Then replace x bar comma y bar equal to x comma y. What do you get now here? Ax whole power 2 by 3 by whole power 2 by 3 should be equal to a square minus b square whole power 2 by 3. So this is our required evolute. Okay, so this is the way we can follow the procedure to construct an evaluate of a given particular curve. Okay, anyway, thank you.